This is AP Calculus AB Worksheet 11-3 for volume of square cross-sections. In each of these problems, it looks like we have calculator enabled. Let's dive right in. In number one, and in fact in all of these problems, essentially we have a checklist of all the things we need. First thing we need is we need to figure out which function is on top. Second thing, we need to figure out which function is on the bottom. Third thing we need to find are the bounds. And then we're going to simply apply the formula, which is the integral of the bound from a to b of our top function minus the bottom function, that quantity squared, over and over and over again. Here we go. For the first one, do we have the top function? It says that the top function is just y equals 6. So the top function is just 6. The bottom function is this 4 natural logs. So I'm going to label this the bottom function. And then the bounds look like we go from 0 to 2. We have everything ready to go. Let's plug everything in here. So this is going to be the integral from 0 to 2 of the top function, 6, minus the bottom function, which we're going to write out again, 4 natural log of 3 minus x, 4 natural log of 3 minus x, and that entire thing, quantity squared, dx, and we're done. We just need to plug this into the calculator. So it's going to be math 9, and then it's going to be 0 to 2, and then I'm going to type in some parentheses because I know I'm about to square this, 6 minus 4 natural log of 3 minus x, and then end those parentheses, and now I'm on the outside. I can square both those functions and hit enter. And I get my final answer right into 3 decimal places automatically, 26.267, and done. Same thing for number 2. We need the bounds. Got them. They're between 0 and so it's from 0 to 2. And I know that we're going to do top function. Top function, ooh, which one is top? Is it sine or is it x cubed? So one thing that I happen to know about the sine function is it immediately starts at 0 and then heads up, and then it's a sine wave that will keep going over and over again. My x cubed function, it's a little bit hard to explain x cubed, but if I plug in a number like 0.5, this number gets really small, and this number gets proportionally small, but this gets smaller faster. So the negative takes over, and it does go negative before it goes positive, and this starts outweighing it and becomes positive and goes off the graph. So I can tell that my top function in this case is my sine function, and my x cubed function is my bottom function. You have to use a bit of logic to figure out what's going on here. And I'm seeing that this S needs to be moved over, this small typo here. If you find any other typos, please let me know. I typed this, and for some reason my autocorrect turned off when I was typing these by hand. So this is going to be on the calculator. Let's write this down before I do the calculator. This is going to be the integral from our bound from 0 goes to 2, right? 0 to 2, yep. The top function is going to be sine of pi x, and the bottom function is going to be, come on over here, x cubed minus 4x. And make sure, so this is careful. I've entered this incorrectly right now, because right now this minus sign needs to distribute into each of these, and it's not. But if I put parentheses here and say it's this function minus this entire function, now this is a correct statement for that subtraction. And then all of this is going to be quantity squared with a dx over here. So if you don't have parentheses here, you will get the answer wrong. And I know I make a huge issue of saying which one is on top and which one is on bottom. It doesn't matter that much, because these squares will always make it positive. So it doesn't matter unless it's like a free response question where you only enter this. Then maybe you might lose a point. So again, I'm going to do math 9. The bounds are going to be between 0 and 2, yet again, just like the last problem. And now it's going to be a sine of pi, which is second to the power of pi x. And then end the parenthesis there. And, oh, I forgot to start my parenthesis. Let's come back over here. I'm going to hit second delete to insert a parenthesis so I don't overtype it. And then inside the parenthesis, I'm going to subtract. I'm going to start a parenthesis to keep all of this x cubed minus 4x in a parenthesis. So it's going to be x cubed minus 4x, and then I'm going to end the parenthesis, ending that function, and then I'm going to end the parenthesis, ending the subtraction, and then I'm going to square that subtraction. And when I do this correctly, I do get this value in pen of 9.978 for my final answer. Do I really need to box these? I did the first one, so I'm just going to continue it on. All right, moving on. What's our top function? Ooh, interesting. It doesn't really matter which one is on top, but I can clearly see my bounds are going to be between 0 and 1. Just using some logic here. I do care which one, me personally, as a teacher, I care because I just want to know, but it doesn't matter for the sake of the problem. Which of these starts out by going positive? Well, if I plug in a half, then I can tell generally. If I plug in a half, this is going to be positive, this is going to be positive. Okay, this one is positive. If I plug in a half over here, yeah, this is going to be negative, and these are both going to be positive, so this is all negative. Therefore, this one is the top function, which you don't necessarily need to know, and this is the bottom function. So the volume of that solid is going to be integral from 0 to 1 of our top, which is this 2x times the quantity of 1 minus x minus x. Okay, that stuff, this stuff is all being multiplied, so I don't need extra parentheses here. Minus, and then this stuff is also being multiplied, so it's going to be 3 times x minus 1 times the square root of x, all being multiplied, and this entire quantity needs to be squared with a dx. So that's what I'm going to write or type into my calculator. So this is going to be math 9 from 0. Oh, what just happened? Math 9 from 0 to 1. And then I'm going to start my parentheses here so I can square everything at the very end. 2x, start parentheses, it automatically will multiply for me. 1 minus x. So end the parentheses for that multiplication. I'm going to do the subtraction. Minus 3, start my parentheses. X minus 1, end that parentheses, start the next one. Oh, I don't really need to start the parentheses here either way. Hit delete, and this is going to be square root of x, so second x to the power of 2, square root of x. I'm going to hit right arrow so we're not underneath the square root, end the parentheses for the subtraction, and then I'm going to square that subtraction and hit enter. And I get this number 1.493. Nice. All right, moving on to the back. These don't have pictures. You got to make your own. All right, let's see what we got here. Reading the base of a solid of the region in the first quadrant bounded, I will fix these typos, bounded by the y-axis, the graph of that arctan function and the horizontal line y equals 3. And everything is going to be square and perpendicular to the x-axis. That'll always be true, but maybe not on the actual test. So we'll see. So let me graph these functions. So I'm going to go y equals, and I'm going to graph y equals 3, done. And I'm going to graph maybe I should do 3 as my second function because that was mentioned second. And then my first function will be arctangent of x. So I'm going to say second tangent to do the arctangent of x. What are my bounds going to be? It kind of tells you. It's in the first quadrant, bounded by the y-axis. Y-axis is x is equal to 0, and then it goes all the way to x is equal to 1. Those are our bounds, 0 to 1. So I'm going to say our window is going to come up here between 0 to, we're going to clear that 1. I'm going to do a zoom 0. Hopefully it'll fix it. And okay, it looks like it just strictly cuts it off right there. So I don't know what those intersections are from. So that's nice to know. I'll screenshot this, and then I would like to talk about the graph a little bit. I don't need to know the time. Good enough. So I'll hit done, and I'll copy and delete. So if I paste that over here, technology, it's kind of hard to see because of the black background. Maybe I'll figure out a way to fix that in the future. But there's the graph. So what's going on here is essentially I have, can I add white? I do have white. Good job, Mr. Sandell. So I have this line at x equals 1 that's cutting off my area. So my area is everything inside of here. And each of those are going to be square cross sections. So I have identified what is the top. The top is going to be 3. The bottom here is going to be arctangent of x. So I'll say arctangent of x. And the bounds are going to be between from 0 to 1, we have everything that we need, right? So this is going to be the integral between 0 and 1 of the top, 3, minus the bottom, which is arctangent of x. And that entire quantity squared dx. Okay, so this is going to be equal to, calculator, come on up here, second quit. So it's going to be math 9 between 0 and 1. is going to be 3 minus arctan, which is going to be second tan of x. And then, oh, I forgot to start my parentheses, didn't I? Okay, so let me come back here. I'm going to hit second delete to insert, and then I'll start my parentheses, come back over here. Every time you move the cursor, you have to hit second delete again to do a new insert. The parentheses, I didn't really need it there, did I? And then squared, enter, there we go. So I get, I'll write this down over here, 6.612. All right, what about this next one? So bounded by the y-axis, that's where x is equal to 0. The x-axis, so it can't be negative, the graph of these two things. So let's go ahead and graph this and see what it looks like. So we have a calculator, so might as well use it. Go down, clear. So it's going to be second natural log e to the power of negative x squared. And the line x is equal to 3. Do we have a... nothing else? Okay, so let's go ahead and do our window between 0 to 3. So come up here, clear, and oh, I meant to do clear and 0, 0, and then to 3, and I'll hit zoom 0. Okay, so I think it's pretty clear from the picture. Let's go ahead and screen grab that. So done, copy and delete. And we'll paste it in here. So the area that I'm looking for goes from 0 to 3, so we have those pieces. And I'm just talking about this inner area right in here. So I have identified the top here is this e to the negative x squared over 2. The bottom, there is no bottom, so you can just say it's 0, and you don't have to worry about it, because if you do top minus bottom, saying minus 0 doesn't really do anything. And we have our bounds from 0 to 3. So I can say this is going to be the interval between 0 and 3 of our top e to the negative x squared over 2, and minus 0, which we don't write, and then that entire quantity squared. And then dx, which is kind of interesting because if you think about the powers, this 2 and this 2 kind of cancel each other out, and it's really just doing the integral of that thing. But we can just enter this into the calculator and it'll do it for us anyway. So we'll hit second mode. We'll do math 9 from 0 to 3. I'm going to enter it exactly as I've written it down. So I hit second natural log for our e function, negative x squared divided by 2, and then that entire quantity, so I'm to the right of that now, I hit squared. I don't need parentheses. It looks like divided by 22, but I don't think that's what it means. It means that entire quantity is squared. It's a little bit weird that the calculator notates it that way, though. This is going to be equal to 0.886. All right, and number 6. Oh my god, these typos are killing me. The base of a solid is in the region in the first quadrant enclosed by a parabola of 4x squared. The line x equals 1 in the x-axis, and they're all squares perpendicular to the x-axis. What is the volume? Okay, so we have a calculator. I want to be able to visualize this thing, and I'm realizing now, as soon as I did question number 4, I don't really need the calculator if you can kind of envision what it's asking for. If it doesn't give you anything else in it, like if it doesn't tell you, hey, it's between this curve and it's in the first quadrant, then it's probably just the integral of that thing squared. I'm betting that's what this one is going to be too. But I want to see what it looks like. I have a calculator, might as well use it. So it's 4x squared, and that's it. So what are our bounds here? X equals 1 is the only thing I'm seeing. Maybe I can do a window to x is equal to 1.2-ish, so I can see what's going on. And we'll clear this and make that 0. Let's hit zoom 0 and see what pops up. Yeah, so that it goes off forever. So let's go ahead and screenshot that so we can add it into our notes. Come back in here. Done. Copy and delete and paste. You don't need to do the picture, but I like having it for the answer key. So again, what it's really asking for is we're in the first quadrant, so we're all the way in here, all the way up to 1, and there's the area that I'm looking for. So how do I find that thing if it has square cross sections? You're again doing the bounds between this 0 and 1. It's just integral between 0 and 1. The top of that function is just the parabola 4x squared. So 4x squared. And that entire thing is going to be squared dx. All right, let's go ahead and do that. I feel I'm writing that out. I'm like, wait, can't we do this without a calculator? We don't even need the calculator for the integral in this one. Math 9. Maybe in the future years I'll change that. You'll have to do it by hand. 0 to 1 of, in parentheses, because I know I'm about to square it, 4x squared, and then out of the parentheses, squared again, which is really 16x to the power of 4, but whatever. And I get 3.2. If it rounded to 3.2, that means it's actually followed by 2 zeros. So I'm going to say that this is 3.200 for my final answer. Definitely could have done it by hand. I'm feeling a little bit guilty now. What about number 7? Base of the solid region in the first quadrant is bounded by x-axis, y-axis. Again, whenever you have the y-axis, you know that your x bound is going to be x is equal to 0. It says the graph of x squared plus 1, and that vertical line x equal 2. And look, you can do this without a calculator, right? You can say, okay, it's between 0 and 2 for the bounds, and it's this function, quantity squared. I'm going to write this out without even needing a calculator to prove to you that I know what to do. You're going to do the integral. I know the bounds are between 0 and 2, and it's that function, x squared plus 1, that entire thing, quantity squared, dx. Done. Like, that is the answer. I'm going to show you what it looks like, though. So I'm going to go up here and clear out of this, show you what it looks like, just so that we can see x squared plus 1 between 0 and 2, so the window is going to go, I can leave that there. Just say the window goes to 2.1-ish, sure. And then we're going to zoom 0 this thing, and you don't even need to see that picture, but there it is. For the sake of consistency, we will screen grab all of these things. Good, done, copy, delete, and paste. I'm a little bit too small. Oh, forget that it sizes from the center. Okay, so again, what's asking for is the area right there all the way to 2, so that area right there, and that little piece, for whatever reason I missed it. Didn't need the picture, but let's go ahead and do the math 9, and it's going to be 0 to 2 of that x squared. This one would have been harder to do by hand, but definitely still doable, plus 1. And then that entire, oops, forgot my parentheses, so I'm going to come over here and do my second insert, and I can add my parentheses. And then that entire quantity is going to be squared. And we get this is equal to 13.733. Nice. And number 8. Man, I feel like every single one of these could have been done. Well, I guess this one needed a calculator because you can't do the antiderivative without paying a tax person. So that one needed a calculator. That one needed a calculator. From 6, 7, and 8, and I'm feeling, yeah, all of these could have been done without a calculator. Anyway, let's do this. So, coordinate axis, every cross section is square. What is the volume of the solid? Again, I can answer this one without even seeing the graph, but it's going to be, the bounds are going to be between, oh, what are the bounds? What is this typo? This R needs to go right there. Cross section. Too many typos to count. All right. What is the volume of the solid? I don't know the bounds, but I do have a calculator. I might actually need to use it. Hey, I know this. If I plug in 2 in here, I'm going to get 0. So I'm thinking that the bounds, if it says the coordinate axes, that means the x-axis and the y-axis. If it's talking about the y-axis, that's x is equal to 0. And because I know that this thing turns into 0 when I'm x equals 2, I'm going to guess here. I'll use a calculator to back me up. I'm going to guess it's between 0 and 2 of that graph of 3 times the quantity of x minus 2 quantity squared. And then that whole thing, again, squared because it's square cross sections, dx. Let's go ahead and check with the calculator, though. So I'm going to do my y equals. Let's clear out a view. Whoa, didn't mean to go that far. It's going to be 3 times the quantity of x minus 2 in parentheses squared. And let's make my window all the way out to 3, just on the off chance that I'm wrong. And I'm going to hit zoom 0 on this thing. Yeah, that's exactly what ooh. I see. You don't know an end bound, but this question might be bad. Let me read it to make sure I'm not mistaking any sort of end bound. The base of the solid is the region enclosed by the graph of this thing, and the coordinate axis is if every section is perpendicular to the x-axis is a square. So yeah, it's a bad question, and I need to fix this for next year. So if you're watching this, you're probably seeing this when it's already corrected, and it will say, I don't know how to fix this for now. I have to make a snap decision that'll probably last for years and years. Let's go ahead and say that the end bound, I kind of like the fact that you had to figure out it was 2. So I'll say something along the lines of, and it's between the coordinate axes and the first point at which the function is 0 or something like that. And that will make it so that this is 2. And therefore we can come over here and we can still screen grab this thing, because this is what I call it, screen grab. It's a screenshot, and I know that. I was just being silly, I guess. There we go. So done. Copy and delete. We'll paste it in here. Cool. Well, that's the logic that I'm going to go with, and we're going to do this. So second mode, I'm going to do math 9, integral from 0 to 2, and we'll say that this is 3 times the quantity of x minus 2, and the quantity, I forgot to do the initial parentheses, didn't I? Hold on, second insert, and go like that. What ended the parentheses for me? Squared. All right, and we get, whoa, 24 on the dot, which means we could have done it by hand. Interesting, 24.000 to be exact. Quite interesting. All right, well, a few errors on the video, a lot of typos. I'm going to go ahead and fix number 8 for future years to make sure that this 2 is very clear. And other than that, that does conclude the homework for 11-3 for volumes of square cross sections in AP Calculus AB. Thanks for watching, guys.